Here we have Circuits FRQ Practice from the Physics Honors Unit 7 curriculum. Here are some important formulas. These will all be on the formula sheet. Current, another current formula, resistance formula, and power formula. You don't necessarily need the power formula for the FRQ, but it will be on the formula sheet for the MCQ. You should be using these pretty much throughout the FRQ. Here's a scenario. There are three resistors, R1, 4 ohms, R2, 6 ohms, and R3, 3.6 ohms, are connected to an 18-volt battery. So here's the situation. It's not labeled, but this is what it's going to look like. R1 and R2 are in parallel, and R3 is in series with the R1 and R2. So in part A, we need to find the net resistance of the circuit. First, break down each resistor to find their resistance. Use the parallel resistor formula. So first, we want to find the total resistance of this parallel resistor. And to do this, we use the resistance of parallel resistors formula. I'm not sure what it's called, so I just wrote it down as this. And it's going to be 1 over R1 plus 1 over R2. And if there's more, you just keep going. Since it's 1 over 4 ohms, R1 is 4 ohms, and R2 is 6 ohms, we do 1 over 4 plus 1 over 6. If you recall, it's 4 ohms and 6 ohms. We need to get a common denominator, add, and then we reciprocate at the end. So we get 5 over 12, we reciprocate to 2.4 ohms. So this whole parallel resistor is 2.4 ohms. And to find the total resistance of the whole entire battery, we need to add 2.4 ohms plus R3, which will be 3.6 ohms. If you recall, it's 3.6, and we get a total of 6 ohms. So we need to find the current throughout the battery. Again, just jumping ahead right here, the total resistance will be 6 ohms, like I said before. So to find the current throughout the battery, we must use the formula I equals delta V over R. Since we already were given the delta V and we found the resistance, this is a simple computation. So we use the I equals delta V over R. The total delta V is 18 volts. Again, we recall from the beginning, 18 volts. And the total resistance we just found on the previous part A, 18 over 6 equals 3. Remember, the unit for I, current, is A for amperes, so it's 3 amperes. Over here, we need to find the current through each resistor. So to do this, we need to make a chart. If you were in any of the physics classes, you know that your teacher has probably made one of these charts before. So before we even start, we need to fill in our knowns. So for all of the resistances, we find 4 ohms, 6 ohms, 2.4 ohms, 3.6 ohms, and 6 ohms for each of these resistors, R1, R2. This is the total of the parallel resistor, and R3, and this is the total in the whole battery. So everything that is not highlighted is what we were already given in the initial problem. So for R1 and R2, we know that the delta V is 9 volts because in a parallel resistor, each resistor gets the same amount of volts. And since we already have the resistance, we divide 9 over 4 to get the current. Again, over here, since R1 and 2 and R3 are in series, they again get the same amount of volts. I'm going to restate what I said over here about resistance 1 and resistance 2 in parallel. Since they are in parallel, they each get the same amount of the total voltage. So since there are 2 resistors, we divide it by 2, and that's why they get 9 volts each. So for the current in the total R1 and R2 and R3, we simply divide once again by our knowns. 9 divided by 2.4 is 3.75 amperes and 2.5 amperes. And this is basically how we fill out a chart. So to make it much more simple, make a chart like so and fill in your knowns. When you fill in your knowns, you can use the formulas on your formula sheet to figure out the rest. Part D, find the voltage drop across each resistor. You will probably be asked a question just like this, and here's the explanation. If you made a chart like this, that is extremely helpful because the voltage drop is just the delta V column. So making one of these charts on your FRQ is going to be essential to solving the whole FRQ. You will basically have all of the information you will ever need for each part of the FRQ. So conclusion, today you learned how to show your work on each part of the Unit 7 circuits FRQ. Make sure you understand how to use all of the formulas effectively and remember the units for each of the values computed. Additionally, computational errors are common if not inputted into the calculator correctly. Use this information to completely and correctly complete the FRQ on the upcoming exam. Please reach out to your teacher if you have any remaining questions. Thank you.